So next up is Mark Culverhouse, and he's going to talk a little bit about testing what you build in terms of automation use cases and frameworks, data-driven frameworks to do that. So welcome up, Mark.
Thank you. This one?
Yes.
Cool. So thanks, Marcus. So hello, everybody. I'm Mark Culverhouse, but I'm also presenting work on behalf of two of my colleagues, Tom and Sven, who couldn't be here. So it feels like I'm accepting an Oscar, hopefully, but these guys did the hard work. So I'm going to talk about data-driven portable test automation. So a lot of words. Hopefully it will be demystified as we go on. Okay. This is me. Someone did a joke about wearing the same clothes yesterday. So as much as I like reusability, I won't do that one. 20 years working with service providers, 14 years in Cisco. I like simplicity. I'm a simple guy. I can code sufficiently to create bugs, which other people can fix. And I've got a cat called Alan who can also create bugs. Agenda. So I'm going to recap why we test. It sounds obvious, but when preparing this presentation, actually it was a useful exercise to go through that. I'll talk briefly about data-driven testing principles. So why am I bothered about this? Why am I spending time looking at this topic? An example walkthrough, it's not a live demo, it's not a video, so hopefully nothing to go wrong. Some real-world benefits, so this is anecdotal. I've been working with a couple of customers over the last 12 months on this methodology, on this approach, and we've seen some real benefits. So I'll talk through some of those observations, and then briefly talk about what's next, where we want to take this. As I said, I'm quite simple, so I like to explain from the beginning what I want you to know, feel, and do. So I'd like you to know, hear a reflection on testing, feel inspired to maybe explore this methodology, come and talk to me, and also provide feedback, right? Nothing is right first time, so you're the experts, provide feedback, criticize, suggest improvements. So let's look at why we test and when. So firstly, let's just see a show of hands, apart from the bright lights. Who does any form of testing in their day job? I assume some hands. Okay, so let's take 5 personas. So starting on the left, we've got a network design engineer. Hopefully, we've got some design engineers in the audience today. So typically, they do testing to design features, kick the tires, test out some new capability on a device or on a system. What we observe is it's sort of design by discovery. So they've got a config guide, they've got some TOIs. They're testing to see how they can use a new feature for their benefit. Obviously, they do security testing, and you can see security testing for everything because everyone does security testing, right? But we observe that mostly design engineers do manual testing. No fault of their own. Historically, they just want to jump on a sandbox, kick the tires, configure something, say, yes, this CLI does what I want it to do, and then they move on. We've got network automation developers or engineers who are normally building software packages, NSO packages, NSO services. There can be unit tests, but also user acceptance tests. So where they say, this is my use case, this is the definition of done, and I'm going to test that that definition of done has been achieved. Of course, they do security testing because everybody does, right? And generally, we see happy faces. It's more automated by, surprise, surprise, automation developers than if we reflect on our network engineering colleague. We then have testing teams. Specific teams designed to do integration testing, scale testing, performance testing, putting everything together. We see pockets of automation. We see people say, yeah, we've automated 80% of our tests, but there are things that we do manually. We pull out a fiber, we pull out a line card. There are robots which do that, so it's just an excuse, but there is more automation in those testing teams. We then have deployment engineers who go out and roll out the physical network. As part of their job, they do NRFU, network ready for use testing. Typically, this is a Word document. which makes me sad. And they do like an eyeball verification at 2 o'clock in the morning to say, looks okay. Obviously, they do security testing. And this is always manual, right? It's normally in a data center, no Wi-Fi, laptop connected via a console cable, and they're just following a method of procedure. And then we have ops engineers, and they do pre or post checks during changes. They'll do testing during troubleshooting, sometimes proactively. We're seeing some customers talk about things like chaos engineering, where they will proactively inject a problem into the network so that they can see how the network responds. But it's generally script heaven. So a plethora of, here's a bunch of scripts on a jump server that just randomly interact with the network. So if everybody is testing, either I'm really bad at time management, and I should have dragged this out for a bit longer, or there's some problems. So maybe the design engineer says, I'm just going to log in and quickly make this change because I just need to see if it works. I'm going to ignore TLS, SSL for now because I don't need it. I'm going to confirm this via CLI, APIs and RPCs are for someone else, not my problem. Then we see the network automation engineer saying, does this config even work? Has this even been tested? I'm trying to automate this, but the box doesn't accept the config. Or is there some prerequisite config that's required on the device? Network test engineers might be asking, how do we scale this? If we talk about telemetry and we talk about dial-in telemetry, how many dial-in servers are we going to have in production to actually mimic the load, representative load on the box? And, oh, I've got an Excel macro that's going to generate the entire device config for 10,000 services. I'll just bulk dump that config on the box and see how it behaves. We've already flamed the deployment engineer for using Word and text documents, but generally we observe that maybe deployment engineers don't look at the logs unless there's a problem. And then ops are left at the rough end of the stick. Why are we using plain text protocols? Why is this sensor path broken? How do I know if the network is even aligned to the design? So we see a lot of opportunity for improvement, right? What if we democratize test cases? What if there was a single test case library that everybody used? And what if that was version controlled and data driven? Would that provide any benefit? Because there is huge inefficiency in each one of these people writing an NTP test case. And personally, if I see someone create an NTP test case again, it's a sad day. So how do we go about this? The first thing is we need some principles. Now, whilst I said I want to democratize test cases, you need a certain level of direction and dictatorship to set a clear strategy and to define the principles. We need a single source of truth, which is easily said, difficult to achieve for config templates. We don't want people using a different version or a different flavor of a config template. If this is what the network engineering team have designed, this is what the automation team should be using. This is what the test team should be using. We want clear design and operational requirements. There should be no ambiguity, right? I should be able to give a test case to an LLM, and it should be able to understand it because it's clear. They should be atomic test cases, right? If we've done a number of surveys in terms of what prohibits or inhibits people from reusing scripts or test cases, and complexity is the number one thing, right? If you open an automated test case and it's 1,000 lines of Python or robot, and you don't understand that, you're going to look at it and you'll say, meh, too complicated, I'll just do it manually. I'll go and copy paste some config. Next comes something that sounds obvious when we say it. We want to decouple the test case procedure from the test case implementation. Okay, so we saw 5 different personas, 5 different use cases for a test procedure, and they may have different needs in terms of the system that are running those test cases. But the test procedure itself, the actual steps that test case describes, should be common. It should be vendor agnostic. So if you want a procedure to say, is BGP up, You don't need to embed the vendor-specific CLI into that procedure, right? And it should be a binary pass or fail. If something passes with exception, you spend 20 minutes explaining why there's an exception. If something fails, you spend 20 minutes explaining why it's failed, right? Just make it easy. It's either passed or failed. We want data modeled everything. So topologies, we want configurations, we want KPIs. Nothing should be hard-coded. Hard coding is just going to inhibit reuse. And this is all data management, right? It requires some effort. You're going to need to appoint somebody to make some decisions, and it requires some thought, but we believe it's worth it. There's no need to reinvent the wheel when it comes to automated testing. There's a plethora of tools and frameworks out there that you can already choose from. They may not be perfect for your needs, but ultimately you need to balance perfection with getting stuff done, okay? We talk about automation being a journey. Anybody who's got kids and you go on a long journey, what's the first thing they say after 5 minutes? Are we nearly there yet? So it doesn't matter where you're going, you need to drip feed output. And if you're striving for perfection, you're going to be slower at delivering results and output. Ideally, your test framework should align with the operational framework. So if your operational model uses netconf yang, if your operational model uses gRPC, there's no point testing with SSH. Right? If you've got 100 tools which log in parallel via SSH, you better make sure that your testing logs in with 100 tools via SSH. Wherever possible, use APIs and RPCs. This is a skill set shift. This is a mindset shift. This is a need to educate our colleagues. Some people are way more expertise with APIs and RPCs. Let's help them along, because doing things with CLI is hard, and it's not scalable. Don't forget your testing principles from the first slide, and focus reuse on the right granularity. A lot of customers have adopted robot framework, and they say, hey, I've got a library of reusable keywords. Okay, cool, but you still got 5 people writing the same test case using keywords in a slightly different order. Maybe the level of reusability should be at the test case granularity, not the keyword granularity. So let's take a walk through an example. So I said it starts with a single source of truth for design and test. So this is a suggestion that when we talk about design and we talk about the network engineer designing feature templates and configuration templates, there should be some logical structure to that repository, to that project, which stores the various templates. So you can see at the top, we've got design and test, ACL, BFD, interfaces. So let's dig a little bit deeper into the interfaces template. We've got a number of different types of config templates, but we can easily see that if this device is running XR and we talk to it using a CLI interface, this is the template for interfaces for XR. Equally, if we've got devices where we interface with OpenConfig or Sonic, we've got the same intent, just in a different format. We've got a data model which would populate those templates. There's only one data model. It's irrelevant whether it's a Sonic template or an XR template. The parameters are the same, right? So don't overcomplicate it. And then we've got tests. Now, I'll skip over the actual robot files for a moment. Test case designs. Test case design is the test procedure. And we've deliberately chosen Markdown for this for a couple of reasons, which I'll dig into in a moment. Beyond that, we've got network services, we've got node builds, and then test bed and topology files as well. So this is just an example. You'll see it's very simple. It's self-describing. If we talk about those network design engineers who may be at the start of their automation journey, this is quite easy to understand. They say, OK, I need an interface template. I'm running XR CLI. This is where I'm going to look. In terms of decoupling test case procedure, so it should be concise, comprehensive documentation. Just back to the previous presentation where we talked about good documentation helps an LLM learn. We believe exactly the same is true for test cases. the better that you define and document your test case procedure, when we look ahead and we think how we can use GenAI to support testing, having a well-structured, well-documented test case procedure is going to pay dividends. In the two text files, so we've got just a pure markdown structure. In this case, we chose to use behavior-driven development to define the high-level test case steps. I'll go into that in a bit more detail in a moment. We identify relevant config templates. We identify the data models for design templates that are relevant for this particular test case. We identify example outputs so that we can prove to the test automation engineer or the scale testing engineer, yes, this test procedure more or less hangs together, right? This has been ran through at least one device. These are the sensor paths that we're going to use. This sensor path works. It gives the data that I need back. And it's a pass or fail. It's got explicit pass or fail criteria. How many of you are familiar with CXTM, CX Test Manager from Cisco? I see a handful of... Okay, I strongly recommend that you look at it. It's one of the best, most, I would say that. It's a very comprehensive test manager which helps us structure test data, so topologies, device types, test cases, how we link those test case procedures to automated test scripts. But it also takes some of the project management burden away. So we can provide data to project managers in terms of how many tests have passed or failed, how many tests are yet to be performed, how many test cases are in this particular test campaign, which test case has not been ran for the last 6 months. So when I said this is about data management, tools like CXTM make people's lives incredibly helpful. And it has an API which you can also hook into CI/CD pipelines as well. Testbed versus topology. So when I included in the title that this is data-driven portable testing, the concept is that a test case can be ran against multiple different topologies and test beds without having to change the test case itself. Okay, so if I'm testing NTP status or I'm testing that some configuration changes, I want to be able to apply it to a variety of different test beds or topologies without changing the test case itself. It doesn't make sense. So I've decoupled the test bed topology from the test case. There's no hard codings in the test case. And then you can point the specific test case to specific topologies. Based on the data that was in the test case procedure, you also then have opportunity to say, well, these N test cases can all be run in parallel. There's no dependency for these specific devices to be interacted with by one specific test case. And that allows us to run tests in parallel, shortening the duration of a regression cycle. I've put consider parameterization of interface names. Anybody who's worked with virtual devices probably has come across the fact that they have generalized interface names, gig 00, blah, blah, blah. So if we parameterize the interface name, that gives us opportunity to then hydrate or populate those particular parameters based on a given topology. So again, less hard coding. I talked about BDD a second ago. So this is an approach that software developers use when they're designing the requirements for a specific feature or user story. And we decided to trial this against network feature testing, where we said, what if instead of saying this is some configuration or this is a test case, let's describe the expected behavior. So let's take an example. Given IGP fast convergence is configured and operationally active, and end-to-end traffic is traversing on a core link, when core link has failed, then forwarding impact is less than 50 milliseconds, and pre-computed backup path is installed. Now, the beauty of this is that's the requirement. So the design engineer has now got a clear line of sight in terms of, okay, this is the expected behavior. I can now go away and find the configuration that implements exactly that behavior. I don't implement redundant lines of config which don't contribute specifically to that behavior. It also forces or steers the design engineer towards, how am I going to verify this? If this requirement's coming from operations or the product team, what verifications might they be using in the real world, in their day-to-day? And then the way that I'm going to verify that the traffic forwarding impact is less than 50 milliseconds is aligned to the operational model. One of the benefits that we've discovered when we tried this methodology end-to-end across an organization is the concept of peer review. So platforms like GitLab, GitHub, one of the biggest benefits that we found with this multidiscipline test framework was a design engineer can create this test case procedure, then get the operations team to review it, right? And any refinement can be updated in the tool. You can see the feedback. There is a mindset shift there to break down that barrier where people don't like their work to be graded. But as soon as you do that, the benefits start to come through. And obviously, this feeds forward to the network test team when they're doing testing as well. I realized when I was stood there that suggesting that network engineers generally do 4 things just before we're going to go on a boat for 3 hours might not have been a great idea. But generally speaking, network design engineers do 1 of 4 things when they're testing a new feature. They render stuff, they configure stuff, they might want to execute an exec level command, and they collect stuff. At this point in time, they can't perform automated verification or validation of the behavior because they don't know whether the box behaves correctly or not. So if we're looking at helping a network design engineer adopt an automated test methodology, it really helps to provide some templates. And providing simple templates to render stuff, push config, collect stuff is a massive accelerator. So 3 examples of very basic test cases that should be readable to the majority of people to be able to perform a particular task automatically. And you might say, well, why wouldn't they just do this manually? Well, if they've got a number of devices that they need to execute the same configuration on, or the same verification, if they've got 4 devices, technically all running the same software version, but they're 4 hardware platforms, you want to make sure that they all behave in the same way. So immediately you're doing something 4 times, doing something 4 times manually doesn't make sense, so automate it. And this allows for rapid validation of that config intent. A comment on over-rotation of parameterization. So parameterizing is good. It allows for reuse, but it also inhibits readability. So when we were working with some of our customers, we recognized that there's merit in, yes, having generic templates with parameters, but actually the test case itself that sits with the test case results should be self-readable. It should be fully rendered so that somebody can read it top to bottom. They don't have to go and look in a data model. They don't have to query separate files to say, what does parameter look like? So there is a point where it's better to actually have an absolute rendered test case rather than an overly parameterized template. What we observed was after a very short period of time, you start to build up a library of reusable test cases. And these are very, very small test cases. So easily leveraged by other people. You can imagine that if these are the test cases that have been written during design engineering, somebody writing an NRFU would be able to say, yeah, I'm going to do an NRFU on this device, and I'm going to cherry pick the test cases which make sense for my job. This is how we're promoting reuse. It's also transparent, so there's no complexity in these test cases because they're so atomic. The version control and test manager tools also help manage that snowball of test cases from growing out of control. What we have seen in the past is that test plans only ever grow. No one ever deletes a test. But if you have a test manager tool which can say, this test case hasn't been ran for the last year, do we still need it? Now, if somebody says, yes, we're still using that feature, it drives a conversation of, why aren't we testing it then? Equally, if we've got version control on those test case files, and somebody says that test case hasn't been updated for the last 2 years, again, we can ask, is that valid? Is there opportunity for us to revise it? Have operations seen anything in the real world which would improve the robustness of that test case? And this really democratizes testing, right? We're saying this is a library of test cases that everybody can use. Change isn't always going to be easy, right? And so this has to be crawl, walk, run. We have to take it slowly, especially when it's cross-organization. We often find that teams and silos and customers don't talk to one another freely. Yet, if they were able to reuse assets because they were immediately obvious, perhaps some of those barriers would be broken down. The starting point in this journey is going to depend upon where the customer sits in their maturity of infrastructure as code in general. So this is infrastructure as code, and if all of their config templates still reside in a Word document, obviously they're at the start of the journey. But for somebody that's already adopted Git or templating of configuration, then the foundations are already in place. If nothing else, look to embrace Git for version control and peer review. If you can solve that across the entire organization where everybody refers to the same source of truth for configuration templates, test case intent, test case descriptions, I think there's massive advantage to the organization. Standardized toolkits. So we lowered the barrier of entry by saying, okay, everybody's going to want a containerized instance of a network element on their laptop. Everybody's going to want a test automation tool on their laptop. So standardize the toolkit, make that available as a single VM so that everybody has the same VM and they don't have to go off to Google to find out how to install Docker on their laptop and then download XRD or SR Linux and start from scratch, right? Make it easy for your colleagues. Pipelines and CI/CD will come. I suspect that the network test automation team are already particularly familiar with pipelines and CI/CD. But over time, we saw that the network engineering team were also pushing new templates to central labs via a pipeline, and then everybody downstream can see the results. Transparency breeds collaboration. It also breeds respect. So by sharing templates, test cases, code, people start to look at it, they start to understand it. Peer review becomes a fact of life. It's no longer a criticism. It's a constructive suggestion to improve. And obviously celebrate success. So after 12 months, some quotes from a couple of the customers that we've been working with. There is a degree of pessimism on some of them, see if you can spot it. So the network engineering team are getting feedback on design changes much faster. So no longer are they making a design change and somebody says, yes, but that's going to break this. They're also saying that it's easier to stay informed of how operation engineers interact with the network. So if operations have seen a particular behavior in the real world, and they say this particular sensor path or KPI or collection helped us identify it or spot the problem sooner, then they can feed that back into their feature test and their feature design. The network automation team, less celebratory, but saying they're starting to perform as a single team. Less complaints to the design team saying, you've asked me to automate this, but it doesn't even apply on the box. So they're seeing a bit more of a one-team perspective. The network testing team was saying, okay, we've seen how this has been designed, we've seen how it's been tested, so it makes our life easier when it comes to integration and scale testing. Biggest benefit for the deployment team was, hey, we can build an NRFU in minutes. We don't have to think about building this out from scratch. We don't have to go to Word and press File New. And we can execute the NRFU automatically. And Ops saying that release management is not easy. This was a big challenge that we faced where things are moving at different cadences and trying to make sure that everybody is using the same version. Branch strategy was a big learning lesson for a couple of our customers. But generally, the feedback is very positive. So if we look forward, what do we see the opportunity to be? So if you've democratized testing, if everybody is using the same test case library, when we talk about training an LLM or an AI, then things are far more repeatable, things are far more accurate. We also see opportunity where if the same test case, literally the same test case, is being ran multiple times in different environments, the results are something that's able to be correlated. You can start to look for anomalies. So yes, we have pass-fail on the test case criteria, but you can also start to capture the unknown. So you can capture a lot more of the data coming from a network device or the systems and say, these tests have passed, but for some reason, memory utilization on this particular process has increased. So you can start to look for the unknown. We think if we combine this with network digital twins, this will be a game changer. So you have your testing intrinsically linked with a carbon copy, a digital twin of your network. So you want to push a change to production. It's not just a matter of whether that change renders and applies, but it can also work through a bunch of what-if scenarios. What if there is a failure? What if somebody adds X, Y, and Z? So we think AI to drive digital twins and accelerate that computational power that we have for testing is going to be an interesting area. Diagram to data model, as much as data models are attractive, we've got some prototypes where people can create a network topology diagram using draw.io, and it spits out a YAML file. So again, lowering that barrier of entry to say, this is how people design a network topology, they don't design it in YAML. And then sort of the last one is an open question, and I'd be really interested in your feedback this evening or this afternoon. What would be the appetite of the service provider community to have a closed community who could benefit from a community-based test case library? Should you be writing the same test cases as your contemporaries? If everybody was sharing the same test cases, could you move faster? Could you innovate? Could you focus on the things that matter to your business instead of potentially creating the same test that someone else has already created? Moreover, if a vendor was providing that test case library, you could open a attack case to say test case 45 has failed. Everybody immediately knows what test case 45 is. How much benefit would that be? So I'd be really interested in your feedback throughout the afternoon. And with that, I'm a bit ahead of time, but thank you very much. Open to any questions.
Thank you so much, Mark. We do have some questions in Slido, or at least one. So let me promote that to the screen. This user interface. Let's have a look.
Good question. I don't want to suggest that execs are like the kids in the back of the car asking if we're nearly there yet, but I think it's about velocity and value. So with my kids, if I'm on a 10-hour journey, telling them it's a 10-hour journey and there's a prize at the end doesn't really wash, right? I have to drip feed either candy or songs or something, right? So I think when we look at testing or any form of automation, it has to be, well, what frequency of value do those sponsors higher up the organization need to stay interested? All right, thank you.
So please keep sending us your questions. We can bring them up on screen if you have any. Maybe, Mark, could you elaborate a little bit more about your idea that you launched here on having like a community supported test framework? Is that something you're kind of nudging?
Yeah, I'd like to know the compelling reason why people might not think it's viable, right? Moreover, if we've got new features like SR v6 microSID, if a vendor was saying, here's 50 test cases to exercise that feature. Here's a bunch of config templates to instantiate it. How much benefit that would be for your organizations to stay ahead of the curve for innovation. So if people feel that there is a political or any other reason as to why a shared library of templates and test cases isn't achievable in the real world, let me know.
Yeah, you're thinking these test cases could be free of vendor bias and
Correct.
just be fully reusable across vendors and systems.
Yep.
Yeah. We should have had a poll on that, I think, in Slido, in hindsight. Something for the next session. All right. Yeah, we don't have any more questions. Maybe we can kick off the next speaker a little bit early. Let's look into that. So we're going to return. By the way, thank you so much, Mark.
Thanks, man.